Warning! Tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, it's time to start testing these Elekit amps. And I don't have a good preamp yet to drive these with, or I'm still kind of on the fence. I don't have a color preamp built. I've sold them all, so I got to get one of those built. I want to get this little guy up and running. I've got an AEMA preamp that's got the tubes in it that people say is a really good sounding amp. I've got a little Fozzy, the early one that has no chips in it, that's got a couple of tubes that I've listened to before that sounds pretty good. But to start with, we're just going to be running these things directly off the audio analyzer suite and doing frequency power sweeps. I mainly want to test how this thing performs with different output tubes and what kind of power it makes with like a KT-88 versus KT-120 versus a KT-170, and then look at what the frequency response is on all of those using the tubes that Victor Kung said are his favorites in the amp. So we're not going to be changing the driver tubes, and we'll go over what those are in the video. But let's see what's going on with these amplifiers. Here we go. Okay, so time to do some testing on these Elekit TU-8888 push-pull monoblocks. And obviously I've got a pair of these. One of these is as built by the factory manual, and then the other one is the one I did a couple of minor tweaks on. But I'm going to show you the stock as designed performance. We're doing this first test with a KT-88. Let me go ahead and get this started. These are some Skunkie KT-88-Zs, the Black Bottle Treasure ones. I've used these in single-ended and push-pull amps, comparing them to Gold Lion KT-88s. And I sold the Gold Lion tubes after listening to these. I really prefer what these Treasure tubes sound like, and they've always performed really well in THD tests. So as you can see here, going past 10 watts, we're just a little over 0.1% distortion. It's going up a little bit here, which is pretty normal, and then boom, it takes off for the moon. Normally when I see a trace like this that has this little dip and then it turns almost vertical, the amp is clipping right here, or where it starts to clip. And we're going to go over to the scope and I'm going to show you what I'm talking about. So there's 0.613 right in this little dip, and there's what 0.613 looks like, and you can see this top edge is flattening off. Let me back it down to like 5.5 just so you can, or 0.555, so you can see what a clean sine wave looks like. See how that top part poked up when I turned down the volume just a little bit? And then let's look at 0.8, and I can show you how really hard this amp's clipping in that zone where it's going vertical. And that's not just a little soft clip. That is a Cookie Monster taking a bite out of a cookie clipping. That is not going to sound good. And that's actually the kind of distortion that can destroy speaker drivers. You can see it's going up, and then it comes back down. You know, the voltage goes up, and then it goes back down. It's almost like a square wave, and the bottom's not clipping. It's all clipping here on this top of this trace here. So this is not normal. And I will say though, for marketing reasons, if they're claiming that this amp makes 50 watts with KT-88 tubes at 10% distortion, They're not lying. It does. It's making an 8% distortion at 50 watts. But it's also hard clipping. In my opinion, and the way I rate my amps and all the other amps I've ever tested, the onset of clipping is where I call the max power. And on this amp, it's at 25 watts with the KT-88 tubes. So, I'm going to turn the amp off. Oh, and again, got the bias set on the left side of the green scale at 50 milliamps, and definitely have the balance in the center in the green. We're using a Mullard EF86 and another new old stock 1287. I tried some different driver tubes and didn't make any difference. Got the same distortion profile and the same clipping started. So let me put the KT-170s in and let the amp get good and warmed up, and I'll show you what that looks like with the big tubes in it. Okay, so now we got a pair of fresh KT-170 tubes. Got them biased up just to the right edge of the green zone, so they're still in the green bias area, but over close to the right edge. And we've got them balanced, not just in the green, but in the center of that green area. So this is probably as good as we're going to see out of this amp. And let's see what it does with these max effort tubes in it. Again, we're starting off down at 0.1% distortion, which is really nice. At 10 watts, we're seeing very similar performance to the KT-88s. And there it goes again. And this time, up to 38 watts, everything's looking great. And again, it just heads for the moon. And again, if you're looking at this spec sheet, which I didn't really pay much attention to when I was buying these amps, it says it makes 60 watts at 10% distortion, and it meets that specification. But again, let's look at our scope pattern here. We're going to pull up 0.675 and see what that looks like. Nice clean sine wave. Let's go to 0.69. And it's just starting to clip there. And that would be, let's see what 0.69 is. That's right there in that little dip. And let's see what 0.7 looks like. I'm pretty sure it's clipping. Yep. You can see it's got a little dent in the top of it. And if we go up to 0.8, I'm sure we're going to see the same thing. Big chunk taken out of the top. And while that hasn't reached 10% THD yet, that's heavy, hard clipping. And 0.8 would be at 50 watts. So this area in here, to me, just is not usable. And the amp stops making usable power at right at 38 watts with the KT-170s biased as hot as you can put them in this amp. Now, obviously, if you're listening down in this range in here, like which a lot of us are going to be doing, like if I, when I'm listening to these things, they sound great, and we'll do that in another review. But my 2A3 only makes 5 watts, and it's plenty of power. So I'm listening in this range right here. So these things sound great. But I don't need a KT-170 push-pull amp to listen at 3 or 4 watts. I would more likely be using these in a larger room with lower efficiency speakers. And if we were even having transients go into this power level, it's going to be a problem, and honestly could probably damage your speakers. And so, if you're going to be using this at low power levels and you're never going to be going past like 20 watts, the KT-88s are probably okay. And these KT-170s absolutely would be with the amp as it comes out of the box, built just per the instructions. But I wanted to figure out what was going on here because this doesn't make sense that it would start clipping this early. Given the power output of these tubes, this thing should easily be able to make 50 clean watts. So let me put the other modified unit up and show you what it looks like on this same measurement. Okay, so we've got the monoblock with the Skunkie mods done to it, and it was a very minor mod. I'm going to do a whole video about how I figured out that this was the problem and the things that I thought maybe needed much more major changes to biasing the EF86 and things like that. Turns out all it needed was to replace the ZD1 Zener diode, which is a 15 volt Zener diode, with a standard, doesn't even matter what kind of diode it is. I think this is just a 4007. Doesn't need a Zener diode. Actually, the Zener diode is what was causing the problem. And the other thing that I did to make it clip symmetrically was I biased the 12AU7 slightly hotter. And I did that by replacing one of the 1 meg resistors with an 820K resistor. And that just moved the bias point up a little bit on the load line and made it where now the amp clips symmetrically. So let me show you what it looks like now with a pair of KT170 tubes biased in the same place. So here's this screen, and then I'm going to just jump ahead to the final measurement. And here we are. You can see now we're making 50 watts at 0.4% distortion. And I believe that is where it's just barely starting to clip. And if you go by this 10% distortion number, it's making almost 70 watts now at 10%. So let's look at this number right here, which is our 50 watt point, and that's 0.78 volts RMS in. Let's come back to our scope. Let's first do 0.75, because that should be a clean sine wave, and it should help us see. Yes, 0.78 is 50 watts, and not seeing any clipping. Let's see what 0.8 looks like. I would say that's just a breath of clipping, and that's not going to be audible. So let's call that our max power point, and that's 52 watts at less than 0.5% distortion. That's freaking impressive, especially for an old school split load phase splitter. That's some impressive performance. And especially when you consider that we're running 450, 460 volts on the plates of these tubes and not like 600 volts. I mean, you could get 100 watts out of a pair of these tubes. But for the point these are running at with the old school phase splitter that this amp's designed with, that is part of why it sounds as good as it does, that's much more impressive performance. And for me, I can live with these making 50 watts each. And then we didn't change anything that's gonna affect the way they sound. The operating point of the EF86 is untouched, and we only moved the operating point of the 12AU7 from negative 15 volts to negative 12 volts. So it was just a breath over where it's in a more linear place in the tube. And let's go ahead and make this thing clip. Let's pull up right here at 60 watts, 0.9. I'm sure that's going to be clipping. But see how now it's got rounded edge clipping and it's clipping on the top and the bottom, that's what you want to see. And that's maximizing what we've got to work with. And so if a transient hit that, it's not going to sound bad. So I would say now these are 50 watts below 0.5% distortion, which that's a nice product. And again, where was that at 60 watts? Yeah, we got 3% distortion. So yeah, it is what it is. So let's do a frequency versus THD, and let's see what that looks like. And actually, there's the 15 watt one that I've already pulled. So we'll just go with this. And you can see down here on the low end, if you look at that spectrum screen on the left, it's mostly second order harmonic distortion, which is why this thing sounds so good. And it is interesting that it seems to have a little more distortion in this range in here. Still, 1% distortion. And like most push-pull amps, when it is in this range here, it's more third order harmonic distortion. And let's look at, like, there's the second order, and you can see the third order harmonic distortion is almost non-existent until it gets to 1K, and then it kind of takes over as the dominant THD. But that's kind of what push-pull amps do. It's why single-ended amps sound like they do. They don't do this. And push-pull amps typically do, even with feedback loops like this amp runs. So the other thing I wanted to show you was the frequency response. And this is at about 30 watts, I think. This is 0.6 volts RMS. I don't want to have to pull that again, so let's just see what this is. Yeah, that's at 30 watts. This is the frequency response. Look how flat this frequency response is. I mean, this is just really nice. And that's why this amp sounds as good as it does. The frequency response is just table flat, and the distortion's under control now. And yeah, I'm excited to go hear what these sound like. So I'm going to pop the KT-88 tubes back into this modified amp, and let's see what kind of power we can get out of a pair of KT-88 tubes now in this one that's been fixed. Okay, so here we go with a fully warmed up pair of our Skunkie KT-88-Zs in the modified amp, and let's see what kind of power we get out of this. And I think I've proven that little kink in the line is the clipping point, so we'll make this last thing fairly quick. I just want to see what we can get out of these KT-88 tubes, which are a lot more reasonably priced than the KT-170s, at least retail. In the US, a pair of them are $300. So now, out of the KT-88s, we're getting 60 watts at 10% distortion, but more importantly, right here is going to be where it starts clipping, and that's almost 48 watts. That's what you expect out of a pair of KT-88 tubes in an amp like this. And yeah, I think I can live with that. The little bit of extra power that you get out of the KT-170, again, I have to sit down and subjectively listen to all these tubes. I have some Summit KT-88s that I want to listen to. I've got some KT-90s, I got some KT-120s, and we'll probably do some other audio analyzer suite tests with this Skunkified amp, and I honestly feel like that this amp now deserves the Skunkie Design logo on the front of it, because this has been Skunkified. And yeah, I have to admit, I was a little disappointed when I did the first analyzer suite pull on that amp, and then I verified it on my analog scope with my analog signal generator to make sure that it wasn't something weird with the software, Audio Discovery 2 or something, and it wasn't. It was clipping. And it took me about 15 hours of trying different things, being baffled, talking with some friends, and looking at it going, man, I've tried this, I've tried that, I've tried everything. Where's this voltage spike problem coming from? And the only thing left was that Zener diode. And I clipped the lead and lifted it just to see what it did with it out of the loop, and bam, it fixed the problem. So this is definitely the fix, is replace that Zener diode with a 4007 regular plain Jane diode. Doesn't matter the brand. It's not doing anything unless some weird startup voltage spike happens, and it's there to protect the 1287 on startup. That's the only reason it's there. Once the amp's running, it's transparent. There's nothing going through it. It's not really doing anything. It's just there. When the Zener was there, it was backfeeding voltage to the grid of the 1287, causing all these problems. And then, like I said, we shifted that one resistor from a 1 meg down to a 820K to bias the 1287 just a little hotter so that we got symmetrical clipping, which you saw in a previous segment in this video. We got symmetrical clipping now. So time to officially Skunkie badge these things, do the mods to the other amp, and start enjoying them. So looks like a great place to wrap up this video. Well, I knew these things sounded good, but gotta admit, that's some pretty impressive performance. And especially at that price point, you're gonna have a hard time beating the performance of these, especially if you're looking for a push-pull with that kind of power output, because none of the single-handed stuff's gonna come even close to that. So if you got moderately to low efficient speakers, something like this is probably gonna be some of the best stuff you can get for your money. Obviously, it's got a lot more power than like that ST70 style stuff, given it's using the bigger tubes, and it's got a much better power supply. That's one of the problems. We probably need to revisit that with the ST70, is figure out how to make a better power supply, because when you drive one channel, it makes 50 watts out of a pair of EL34 tubes, but then when you combine the two channels together, they peter down to 35 watts, and that's telling me the power supply just can't deal with it. So that may be a future mod on the ST70. But we're here to talk about these Elekits, and yeah, I think the results speak for themselves. And I hope you've enjoyed this little test session. This is the objective part of the review, and I doubt we're going to dig in much more into this. We may play around with some tube rolling and doing some testing in the future, but the next step is to do some subjective listening. And again, I need to get some different preamps so I can make sure that they're not coloring the sound, and be able to try 2 or 3 different ones and make sure that what I'm hearing is the actual amplifiers and not the preamps. And I got to get one of my color preamps finished. Again, I've sold all the ones I had, so I need to sit down and build one of those for myself so I can have something to drive those with, because they don't have volume controls on them. There's no way to attenuate the signal without having something in the signal path. And my past experience hasn't been real great using those passive kind of preamp things, whatever they call them, but it's just a volume control. I've never really been happy with those. So, and I also need to figure out a way to get balanced input in there off my new CD deck, because that Rotel CD deck is so awesome. Definitely need to be able to hook it up to these and listen to them. So we'll be doing that in the future. So anyway, hope you enjoyed this video. If you did, please subscribe to the channel. Please like the video. Thanks to all you Patreon supporters, people that support the channel in other ways. And until the next video, have a nice day.